Alright guys, so 5.4 really jumps into the meat of this chapter. Okay, so it's beginning to rationalize algebraic, or work with rational algebraic expressions. Okay, so simplifying them and then working with them as a function. Right, so the first thing we're going to do here is we're going to work with these rational expressions. Rational expression is just a quotient or a fraction of polynomials. So if you look down here at A, right, you got a polynomial on top and a polynomial on the bottom. That's called a rational expression. Okay, in order to simplify these, right, that's why we had to do chapter 4 first. You got to factor the numerator, factor the denominator, and you'll be able to cancel out any common factors to get a simplified fraction there. Okay, so A and B here are just very simple examples on how to do this, and then we'll get into more difficult ones on the next page. So this first one here, right, we got to try to factor the top, factor the bottom. So once again, like I said, in class, you really got to be good at factoring at this point. It's got to come straight to you. So we know we've got 5A and A, and we know we've got a plus 1 minus 1. All right, we need to end with a plus 4A, so we need the plus 1 over here, the minus 1 over there. All right, and on bottom, we know we're going to have a 5A and an A. Okay, we need to add to negative 10, and we need probably either a 15 and a 1, or you need a 3 and a 5, and I think that 15 and 1 is going to be the better choice to try to get us to a negative 10. So let's go with a minus 15 here, plus 1 there, and that should get it to us. All right, let's double check. These multiply to negative 5. We got positive 5, minus 15 gets us negative 10. Great, we're done. Okay, so now once you get to this point, we can cancel out whatever's common. So there's an A plus 1 on both top and bottom, so those go away. All right, and you can continue to factor out anything that we can. So we've got a 5A minus 1 on top. Can't factor anything out of those, but you can take a 5, right, out of this bottom one. All right, since you can take a 5 out of that, we're going to end with 5 times A minus 3. Okay, we can't do anything from there on out, so this is the simplified rational expression. All right, so the second one here is, I just wanted to show you this one just because it's written in a different way, okay? Remember, we just worked with negative exponents. Okay, so these are multiplied by each other. These polynomials are multiplied by each other. But remember, since we've got this one over here is to the negative 1 power, right? You're just moving it down to the denominator. So we've got z to the 4th minus 5z cubed plus 6z squared all over 9z minus z cubed. Okay, so this is really the same thing as what we were doing above, just written in a different way. So I just wanted to show you that that's going to be something that comes up, right? So let's factor out everything we can. Take a z squared out on top. We'll be left with, all right, then you can factor this as well, and you're going to get a z minus 2, z minus 3. All right, if you need to review that, or if you have any questions on how I got there, go ahead and ask them in class. On the bottom here, we're going to take out a z, or actually let's take out a negative z. All right, and you'll be left with z squared minus 9 on the bottom, which is the difference of two squares. You can factor that to z plus 3, z minus 3. Okay, now we can cancel out anything that's common. So the z minus 3's will go away. All right, 1z on the bottom goes away, 1z on the top goes away, and what we'll be left with is z times z minus 2 on top, and negative, parentheses, z minus 3, or sorry, z plus 3 on the bottom. Okay, that is the simplified rational expression, right? Now, rational functions, okay, so if you could write a rational expression as a function. All right, if you look down here, g of x is written as a rational expression down here. All right, it's already factored for us because I just want to show you what we're going to do with them. There's two things we're going to learn how to do with them in this section. All right, first one is to find the zeros of the function. Okay, so that's where wherever the numerator is 0 is where the zeros of the function are going to be. And the zeros of the function are where it crosses the x-axis. Okay, so if I draw, right, this right here, we're going to have some the zeros of the function right here are when the numerator is 0, so the numerator is going to be 0 at either x equals negative 4 or x equals 1. So what that tells me is over here at negative 4 and at positive 1, those are going to be the two places that this graph is going to cross the x-axis. Right, and then the domain for this function, so the x's in which this function is real, is all real numbers. So usually you're going to be coming all the way over from negative infinity into positive infinity, except it can't be defined when the denominator is 0, right? If you can't have a 0 in the denominator because the whole thing blows up. So anywhere where the denominator is 0 is going to mess up our range. Okay, so for the domain of this, it's going to be, it's going to be all x's, all x, except, there's supposed to be a c in there. Okay, that says except, just believe me. All right, so all x except when x does not equal 0, right? Because 2x, if x equals 0, then 2x is going to blow up, negative 3 and positive 3. So that means that this graph is going to look something like this, right? It's going to go up forever, and it's never going to touch negative 3 there. It's also never going to touch positive 3, and it's never going to touch 0. So let's just say, for example, it comes back down here and goes like this. This is not for sure, this is what it looks like, but something like that, okay? It would have to look something like this because you're going to have what's called an asymptote at negative 3, at 0, and at positive 3, where the graph is totally undefined. Okay, so that's how we get the domain. I'll jump in examples. Okay, so we're just going to start simplifying and factoring and all that kind of stuff. All right, so this first one here, we're going to begin by taking out a 2x on top, and you'll be left with 4x minus 3, and on the bottom, we just have 4x squared. Okay, so cancel out whatever we can. These can cancel out, these can cancel out. We're left with a 1 on top, a 2 on bottom, and we're going to have 4x minus 3 over 2x. Okay, now remember, you can't cancel any of these out. Okay, can't cancel the 4x and the 2x because the minus 3 here. All right, you can only cancel things out when they're multiplied to each other. If they're added and subtracted to each other, you can't do any kind of canceling. All right, so we're stuck there, and that's all you can do. Next one here. Factor out an x first, and we'll be left with x squared plus 6x plus 9, and on the bottom we've factored out an x, we're going to be left with x squared minus 9. Okay, we can continue to factor. Well, our x's can go away right away. All right, we don't have to do any more of those. All right, we've got an x plus 3 squared on top, and x plus 3, x minus 3 on bottom. All right, and we could get rid of that x plus 3, get rid of the second x plus 3, and we're going to be left with x plus 3 over x minus 3, which you can't do anything with. You're done. This one, number 3. All right, let's keep the top the way it is because that's already factored as a square. The bottom's a difference of 2 squares, so we can do y minus 2, y plus 2. Cancel out one of the y minus 2's. And we'll be left with y minus 2 over y plus 2. That's completely factored, simplified. All right, this one, number 4. All right, I'm just going to rewrite this right away as x plus 3 squared, right, and forget about that. This is just that different type of notation. All right, we could factor the top into x plus 3, x minus 2. You've got the x plus 3 squared on bottom. Cancel out 1 x plus 3, left with x minus 2 over x plus 3, and you're done. Number 5 here. All right, for number 5, we've got a difference of 2 squares on the top, so x plus y, x minus y. And on the bottom, all right, when we factor this, you're going to have an x and a y in both of these. Okay, we need the y's to multiply to positive 2, so it means we need a 2 and a 1. They're both going to be positive, right? Because when you do this factoring, you're going to see that. I would just check your answer, obviously. Make sure you're going to get 3xy in the middle, and you're going to get a 2y squared and an x squared, and you do. So the x plus y's are going to cancel out, and you're left with x minus y over x plus 2y. Now don't forget that you can't do any canceling once you get here with these terms. Okay, when you're adding and subtracting, you can't do much canceling. It's only when you're multiplying, like here. Okay, this last one. All right, so the only thing that I see that we can really do anything further with is right here, this difference 2 squares. So we're going to keep everything else the same. All right, we're going to factor this difference 2 squares. Okay, minus 1. And on bottom, we've got k minus 1 times k plus 1 squared. Alright, so I'm going to cancel out our two k minus 1s and both k plus 1s from top and bottom, and you're left with nothing on top, nothing on bottom, so the answer is just 1. Now the last couple problems here, we're just going to give the domain and the zeros for each function. Alright, so remember the zeros you get from the denominator being 0, or sorry, the zeros you get from the numerator being equal to 0. The domain is everything except for when the denominator is equal to 0. Alright, so for 7 here, in order to get the zeros, you got to factor first. So we've got a a sum of two cubes. So we've got z. What the heck am I doing with z? I don't know what that z came from. So we've got x plus 3 times x squared minus 3x plus 9. Okay, which continues to factor, right? And the bottom doesn't factor at all, right? But this, right, we can continue to factor. That's going to be, I'm sorry, actually you can't factor the second trinomial here because it's actually prime, so it's never going to be equal to 0. So in order to get the zeros for the top, it's only going to be this one that we have to worry about. So the only 0 is x equals negative 3. Okay. Now in order to get the domain, right, we need to figure out, is the bottom ever going to be equal to 0? Well, x squared plus 9 is never going to be equal to 0, so the domain is just all real numbers. Okay, all real numbers works just fine. Now number 8 here, all right, we got to factor the top, factor the bottom, and find our zeros in our domain. All right, so the top here is going to factor out. We're going to pull an x out. We're going to be left with x squared minus x, 3x squared minus x minus 2. And on bottom, we can't factor anything, so we just leave it the way it is. All right, and on top we can continue to factor if we can. Let's see, I think we can do it. We've got x, we've got a 3x and an x. On bottom, we obviously leave it the way it is. So we should have a minus plus 2, minus 1. Yeah, plus 2 minus 1 works well for us. Okay, so to find let's start with our domain. Okay, I think the domain's a lot easier to do here. All right, so it's all real, except the only time that, why can't I spell except? Except the only time that the denominator here is going to be 0 is this one's going to be negative 1, right? X equals negative 1 or x equals 0. Okay? X equals negative 1 or 0. And the zeros of this function, can't spell zeros either. Alright, we've got x equals 0 from the first one. From the second one, when you solve that, you're going to get negative 2/3. And the last one is 1. So the domain is all reals except x equals 0 and negative 1. The zeros are x equals 0, negative 2/3, and 1. So you can plug this function in your calculator. It might be a good thing for you to do. Plug this function in your calculator. You should see that at 0 and negative 1, there's going to be two asymptotes. It's going to be undefined. And at 0, negative 2/3. Oh, wait, that doesn't make sense. Hold on. Yeah, that's not going to make any sense because you're not going to be able to have undefined and 0 for x equals 0. So the one that's going to trump is obviously going to be the denominator because you would normally have a 0 at 0. However, because it's undefined at 0, that's not going to work. So this one is not going to be true. You're only going to have these two. Okay, we'll work it in class.